Cool. Thank you so much, guys. It's a let me just try to fix some stuff here with my. Come on. Can you guys see my? Let's change that. There we go. Can you see my screen? You should see a PowerPoint slide deck. Improve customer lifetime value, yada yada yada. I hope you can see it. So yes, thanks, Jean. Thanks for having me. It's a great pleasure being here at this user group session. I got in touch with Sean. I don't know, a couple of months ago, a year ago. I don't know. The time flows into each other here, but he invited me to Future Data Driven, which was an awesome conference, and I gave a talk there. And Sean must have liked what he saw, because he said if I wanted to do something on cloud data driven as well. So here I am. So thank you, Sean, for everything you're doing for the community. And thank you guys that are and girls that are attending. It's an honor having you here, listening to little old me. Anyway, so I'm Niels, all right? I am a software architect lead at a company called Derivco. We are doing online gaming, software for online gaming. Like casino, sportsbook, etc., etc. I am, as Jean also said, I'm a Microsoft MVP, most valuable professional in the data platform space. And as I'm an old SQL guy. I've been working with SQL Server since version 4.2, when it still was called Sybase, and Sybase was the code base for SQL Server. So I'm kind of a SQL guy, but lately I've been trying to expand out a little bit, not only on my stomach but also in my knowledge. So I'm doing a lot of cloud stuff. I'm very much into real-time event streaming, things like that, and I kind of like Databricks and what you can do with Databricks. So that's me. You see my contact details here. So please feel free to contact me if you have any questions, if you're having any ideas what I should cover, if you think that, hey, you are that this what you said there was not right, etc., etc. Just ping me and let's chat. Eh? Cool. So let's go back to so improve customer lifetime value. Right. So we'll come back to what customer lifetime value is, but it has to do with retention. So imagine that you are a retail company. You're a retail store, whether it is online or brick and mortar, whatever. Retention is important. Well, retention is important in any industry. So for us in online gaming, we want people to come in through the doors. Well, in this case, through the computer. We want people to deposit money and then play, right? And it is much better if we can hold on to someone than to go out and find someone new, if that makes sense, right? So retention is what it says here, a company's ability to retain, hold on to customers over time. And why we want to do that, once again, to get new acquisition is a lot more expensive than to retain customers. And research has shown that acquisition is up to 5% more expensive than retention. And if we can reduce people that are falling off the wagon, that are walking off the cliff, we can increase our profits. And if we can, once again, certain research says that if we can reduce the churn, people leaving with 5%, that can lead to from everything from 25 to 125% increase in profits, which is kind of cool, right? And then if we're looking at revenue and customers, we have the 80-20 rule. 80% of the revenue comes from 20% of the customers. And right, who are those 20% of the customers? Well, that is most likely your most loyal, the customers that has been with you for the longest time, the customers that you have managed to retain. And finally here, it is a lot easier to sell to an existing customer than to a new one. So, oh, and by the way, if you have questions, comments, please feel free to, as Sean said, unmute yourself, scream, or hold up your hand or whatever. I'm quite happy to take questions as we go along. I can't guarantee that I can answer the questions, but we'll see what happens. And then for retention, the customer lifetime value, the CLV, is extremely important. And we'll see that in a second why that is important. So what is CLV? What is customer lifetime value? Well, it is what the customer gives you during its time with you. So it starts with the first purchase it ever does, and it ends then. So it is, well, sorry, let me rephrase. So it is the sum of all the purchases that a customer has done with you from the first time until the customer leaves you to never come back again. And if we are looking at this in graph form, so if you're looking at the graph here, you can see that, whoops, sorry guys. So this is kind of the customer lifetime and a customer lifetime value, where in the very beginning here, you have a negative value because you have spent marketing money, you have had cost for acquisition. And as the customer stays with you, the profit increases because the customer is getting used to you, he buys more, there are decrease in support cost, etc., and the customer becomes more loyal. He knows that if I want to buy this thing, this shop is where I want to go to because I know them, they know what they are doing, etc., right? So how do we calculate CLV then? How do we calculate customer lifetime value? There are three things that we need. It is our gross margin on our product or products. It is the retention rate, and it is the rate of discount that we are giving. And the problem, or so gross margin, I mean, that is fairly self-explanatory. Rate of discount is also fairly self-explanatory. The retention rate may be a little bit, what is that, right? So that is the percentage of customer you have left that still is with you after a time period. So let's look at it. Let's take a year. That at the beginning of the year you have 100 customers. Out of those 100 customers, 90 is left at the end of the year. In that case, you have a 90% retention rate. Notice that we are not taking into account new customers that comes in. We are only looking at existing customers from the start of the period and how many are left at the end of the period. That's kind of the retention rate. And 90%, by the way, is quite a good number. Cool. So that's how we're calculating the CLV. If we now want to increase the CLV, we want to improve the CLV, what do we do? Well, so remember the calculation was like this: gross margin times retention rate divided by 1 plus discount rate minus retention percentage. So what can we now do to increase this dude here, or to that, right? Well, we can improve the profit margin. How do we improve profit margin? We increase prices. So maybe that is not really what we want to do, because we don't want to tell the customer, hey, you need to pay more for what you need to pay more today than what you did yesterday. Excuse me. We can reduce the discount rate. Yeah, sure we can, but definitely customers will be unhappy. If we are reducing the discount rate, they are getting, I mean, they have to pay more, exactly as if we are improving the profit margin. The last one then is that we can increase retention. So if we can increase the retention rate, so if we can, so instead of having a 90% retention rate, we have a 95% retention rate. How cool would that be? So the thing here is that we can't blindly look at retention, saying that those 10 customers that fell over the cliff during this year, or however many it was, we need to blindly keep them. We need to throw money at them, because it may be that those customers were not really any good customers. So we don't want to throw good money after bad. So when we are looking at retention, we also need to look at the CLV. We need to look at the customer lifetime value, if that makes sense. Any questions so far? Are we okay? Are we good? Does it make sense? I'll take that as a yes. Awesome.
Yeah, cool. I'm not seeing any question. However, you guys do have access to unmute yourself. If you would love to ask a question, feel free to raise your hand.
Oh, I see a hand. I saw a hand. Or not. Okay, cool. So once again, raise your hand. Sean will have a look at it and scream if there are questions. Cool. Right, let's continue. So if we look at this, so this is now what we see here is your typical bell curve of, well, of a lot of things. In this case, this is sort of your customer base, where we at the left-hand side here, we have inactive, non-profitable customers. Well, I'm lying a little bit. This could now be newly acquired customers as well. But if we're looking at retention rate, right, then these are now customers that has been with us and they don't give us anything. We don't really want to spend money on keeping those guys and girls. So let's fire those, right? In the middle, right? Here we have good customers. They are staying with us. They are buying from us. They are giving us stuff, right? So let's keep these. Let's spend money on retaining these customers. And then to the far right, we have the the whales, as we call them in the gaming industry, the very active, very profitable customers. If we're looking at gaming, gambling, those are the ones that goes to Las Vegas and are being comped with drink and food and fancy hotel rooms, etc., etc. These are the ones that we really want to keep because they give us a lot of money. And we want to find more of those. And also what we want to do, we will take the guys here and move them into there. Yeah. So how do we now then, I mean, that sounds easy, right? That sounds very easy. How do we now calculate CLV. So once again, right, this is about customer lifetime value. And if we're looking at this this slide here, we need to kind of understand that the customers here, their lifetime value is not that great. Do not spend money on them. We need to know that, yeah, these guys here, they have a good lifetime value, so we can spend money on them, and here definitely spend a lot of money on these guys. Machine learning and CLV. So there are a couple of things that we need to do here, that we should do. We want to predict when customers will churn, right? But at the same time, we need to understand that of these customers that we are running the risk of losing, we need to understand who of those are valuable. Because once again, we don't want to blindly spend money on, let's call it, bad customers. And what we also want to do here is we want to take action in real time. We do not want to get a report a day, a week, a month later saying that, hey, customer 1, 2, 3, 4, 5, 6, 7, 8, 9, whatever, we are running the risk of losing them. We want this to happen immediately, right? So we want to be able to run processing based upon when the customer is active with us, as well as when he or she is not active with us. And there is various machine learning models here to help us understanding churn, help us understanding customer lifetime value. And one very popular model is buy till you die, BTYD, the BTYD model, which essentially says that the model makes its decision based upon the customer's purchase behavior. Someone? Cool, thank you. Right, so buy till you die, BTYD. I mean, we'll look at that in a little bit when we're doing demos here. I'm soonish done with the slides, and we'll go in and look at code. Right, so BTYD, it's not only one model, it's a family of models, and we are modeling the customer's behavior as distributions, how evenly things are distributed, how skewed the distributions are, etc. And we are basing this upon certain key data, such as an identifier of the customer, a customer ID, and an order ID, i.e., the customer at this date, order date, bought this thing, and the value was that. So customer ID, order ID, date, and value. And the BTYD models, they captures RFM, what we call RFM, recency, frequency, and monetary. So RFM, recency. How long ago did the customer purchase? So, i.e., how many days is it between his last purchases now? Let's see. How often has the customer made a purchase since his first purchase up until now? Obviously, then, right? And then how much does this dude or dudette spend on average? That's the RFM. We are also taking into account a fourth parameter here called the H, which is the number of time units. How long time has there gone between now and his first purchase? So those are the four different parameters we are working with when we are using this buy till you die models. I mean, so far it sounds fairly cool. I mean, how hard can this be? What could possibly go wrong when we are doing this? So since I have here a slide that says challenges, there has to be something in here that may or may not be straightforward. And the thing is that when we are talking about retail data, or when we're talking about any kind of data, we're talking about a massive scale, massive scale. We're having point of sale data, we have geospatial data, we have demographics, public, we have lots and lots and lots of data that we need to take into account. And the data is not symmetric. It is not coming in nice little boxes and shapes. It's completely, or could be potentially be completely fragmented. The other thing here then is that, so now we have this massive scale of data, and now we want to build models, machine learning models. Where are our data scientists building these models? Well, they are probably sitting on their own little laptops trying to make sense of the data, where we're now building it on smallish laptops with just sample data. That's data that doesn't necessarily represent data that we have here. Right? And then we have a disjointed development. We're having a data engineer is doing one thing, we have a data scientist that is doing a second thing, and then we have some sort of an analyst who's doing a third thing. And quite often, there is no real collaboration between these group of people. So we are not getting a collaborative effort here. It is fragmented. Okay, so that's kind of where we're at. What can we do? And that's now where Databricks comes in. So Databricks is a analytics platform, and it is based on Apache Spark. So we'll come in a second. We'll come to what Apache Spark is. So the founders of Databricks are the boys and girls that initially wrote Apache Spark. We have so apart from Apache Spark, we have a runtime that consists of Apache Spark. It consists of this thing called the Delta Lake, and then we have machine learning frameworks inside Databricks, inside Spark. And where I said this whole thing about disjointed development over here, right? What Databricks has, it's a fairly cool thing. It has a workspace which allows you, based upon notebooks, where these different people, data engineer, data scientist, business analyst, retail analyst, they can work together in this workspace. They can share notebooks and collaborative develop their models, what they want it to look like. Right. Let's see. Hello. Here we go. So so here is just an example. So this is now a Databricks cluster, or this is the Databricks environment inside Azure. So I have spun up a Databricks environment, and inside this environment now I have over here, I have various notebooks that I'm working on that are now that anyone that has access to this environment can work with, can use, right? I have my compute here, which is now a cluster node, or rather a cluster. This is now a Databricks cluster, cloud that I call cloud data driven, obviously. And we can see here how it, how I have here Apache Spark 3.2. It's the version 10.1 ML, etc., etc. We can see my workers, it's my drivers, so on and so forth. So Databricks is a very, very easy way to spin up a Apache Spark cluster. To do it on-prem by yourself on your own metal is not for the faint-hearted. So Databricks is cool that way. Oh, there we are. Cool. So we have this runtime, we have the workspace, we have Spark. Spark. Back in the day, you who have been working with big data before, you have most likely heard about Hadoop. Well, you have heard about Hadoop. You have heard about Hadoop file system, and you have most likely heard about MapReduce, which was the way that we previously worked with big data in Hadoop. So, and it worked. However, Spark is an evolution, almost a revolution. So Spark is a distributed compute engine. And the thing is with Spark, whereas Hadoop, we had MapReduce, which was essentially batch programming against data in the Hadoop file system. With Spark, we can do batch, we can do streaming, we can do normal SQL stuff. We have Spark supports a lot of different workload types. And also, once again, right, Hadoop, that is Hadoop file system. MapReduce, Hadoop file system. Spark has a variety of storage types, SQL Server, data lakes, Hadoop, you name it. You can use Spark against all of these various storage types. And you have a choice of language, such as SQL, such as Python, Scala, R, Java, and quite recently, .NET now also supports Apache Spark. So the Databricks solution then is that we have the ability to take real-time data so Spark streaming allows for real-time data, and we also have the support of batch. So what we can do here now with Databricks is we are joining batch with real-time data. As we are now working in this big data environment, we can build these models at scale, i.e. we are not sitting with sample data on my laptop. We are sitting with a UI, a notebook that goes against your sort of production data, your big data, right? So we have the ability to build models based upon that. And then this, once again, I'm coming back to this whole workspace where the data engineer, the data scientist, the data analyst, the retail BA, whatever, can work together, because we all have access to these various notebooks that we are using. Sorry, question about that. We good so far? Does it make sense? Cool, I'll take that as a yes. Awesome, right. So a sample architecture, I'm done with the slides in a minute or two, and then we'll start to look at code. So we can take, all right, so we have here a data lake, right? We can now push data through Azure Data Factory, etc., into a data lake. We can also stream data straight into Databricks, but let's go with this picture. So we have a data lake here. We have Databricks loading data from data lake. It may load data from a SQL data warehouse. It can now create models. And then we have Power BI that can, so or rather, let's say that we're loading the data into Databricks, we are creating models, we are saving the output from those models into a warehouse on which we can then use Power BI to create reports and what have you, right? So that's kind of a sample architecture. So the demo that we're going to do is I have some data in Azure Data Lake storage, Gen 2. We're going to connect from Databricks. We're going to connect into that data lake storage. We're going to load the data into Databricks. We're going to explore the data within Databricks to see, okay, so what is this data all about? What parts of the data is interesting here, etc., etc. From there on, we will create a machine learning model, and then we will operationalize it. Well, at least I don't know if we will come to the operationalize part in this session, but we will at least do these three things here. I just want to say that I will be very light on this whole create machine learning model. That in itself would probably take 2 or 3 sessions to go over. So it will be a lot of just looking at stuff, skimming stuff. I will share out all the code so you can have a look at it yourself, etc., etc. So I'm not really a hardcore data scientist, machine learning dude. I kind of know enough to be dangerous. So I don't want to go too deep into this whole machine learning stuff, but we'll have a look at it, right? Cool. Right, on to it then. So here, let me make it a little bit bigger so you can see. So here is, I now have my cluster, the cloud data driven cluster, and I have a we saw where I had my my notebooks, and we are going to use a notebook, the cloud data driven CLV notebook that I have over here. So I'll take that down a little bit. Yeah. Before we go into the notebook, let's just have a look here at my Azure environment. And I have here an Azure Data Lake storage thing, BDC ADLS. Let's click on that one. And let's click on, so this is now a data lake, right? Let's click on containers here. And we have a container that I don't have any imagination whatsoever. So my naming is kind of, yeah, probably not that nice. But anyway, we have a Databricks container. When we click on that, we can now see that in this container, I have a CSV file. And that CSV file now contains retail information from a shop with customers, orders, what have you. And I think it's around 50 meg in size. So it's not 44 actually. So it's not that big, but it has quite a fair whack of data in it. Right. So that's what we're using. So what we want to do is we want to estimate. So we as I said on the slide, we can estimate the aliveness. What is the chance that this? What is the risk that this customer will churn? That is one way to do CLV. And the other thing, what we can do is estimate the future spend. So in this here, I will give you notebooks for both estimating churn as well as estimating future spend. And now we will look at estimating this whole future spend. So how much will this customer spend in the future in my shop? Which is good to know. So we're not throwing bad money after good, if that makes sense. Cool. So what we'll start with, we'll just set up a connection to my Azure Data Lake storage. So we're running here this cell in my notebook. just look at what I have in this particular, well, this is kind of the file system. Let's have a look at that. And we are getting here ADLS. We have a file called online retail CSV, and that's the one that we saw before. Cool. We are using, in most of this, we are using PySpark. So it's Python with Spark. And what we are doing is here, I am reading in from the data lake store, right? So this is not, well, this is the file, but it's not the file. From the data lake store, from the blob store, I'm now reading in the data, and I'm setting up the structure of the data. So I have an invoice number, I have a stock code, etc., etc., etc. I'm reading it as CSV because that is how it's stored in the data lake store, and then I'm creating a computed column called sales amount, which is the quantity of the orders times the unit price, right? So we'll run that somewhere here. And 740, yeah. And here we now have the, I'm seeing 10 rows, whatever, where we're seeing an invoice number, stock code, description, quantity, and then finally my sales amount. Cool. And the sales amount is now interesting for to use when we will calculate the future spend. I'm turning this into a pandas data frames just because I can. And we are seeing the same thing as we did from my PySpark. Cool. Here is an interesting part where we now take this data and we push it into like a table. We're pushing it into a Delta table so we can use it afterwards. Cool. Now let's have a look at here at the data. So we are exploring the data now, and we are seeing that. So this is interesting. We're seeing that here we have negative values, which probably are returns, etc. And if we were to drill down into this, we would see well, sales amounts ranging up to 70,000. I think this is in pounds, which is probably not that common. So what we want to do is we want to narrow down the sales amount we are working with. And here we are now doing it between 0 and 2,500, right? Anyway, so now what we want to do, so now we have explored the data. We have drawn some conclusions of the data. So once again, I'm skimming this fairly quickly because we're getting a little bit short of time. So now we have spent the data engineers, and maybe together with the data scientists, have now spent time looking at the data and understood what the data looks like and what we want to do with the data. And once again, right, this is now sort of live data, production data, and there are huge volumes of this data. And I am working together with other people here. Right? So let's now calculate some metrics here, i.e. frequency, age, recency, and monetary value. And we can do that in various ways. There is a Python library called lifetimes, which actually gives us, which makes this very, very easy to do. I'll come back to I'll talk about the downside in a second. So we're saying here, so we're ensuring that we are just looking at a right time period. So what we're saying is that, okay, the current date, which normally would be today, but the current date in this case is the max value for invoice date for this retailer. And what we are doing is we are using this lifetimes library to grab data such as customer ID, invoice date. We are also saying frequency that we want to do this on. So that is kind of this thing here, frequency equals D, frequency equals daily. And we're saying that the monetary value is sales amount. So we run that. And we now should see here, right, customer ID, frequency, recency, monetary value. And all this will now be input when we are calculating CLVs, whether we are calculating future spend or whether we are calculating churn, the aliveness percentage for a customer. So we can do. So what we are doing here, this is now the Python library. The downside with this Python library is that this is single threaded. And if we are having huge data volumes, it may be a little bit not as performant as we would like. So what we can do the same thing by using SQL statements and using Spark's inherited multi-threadness and Spark distributing out the workload over multiple nodes. So what I'm showing here, so we don't have enough data so that this would be have a negative impact. But what I'm saying, I'm just showing that we can do this with large volumes of data. We can do it in a more performant way by using Spark's inherent way of doing things, distributing out the workload across multiple nodes. Cool, we are doing that. Come on. That took 0.88 seconds. Yeah, so when we used the lifetimes library, that was much quicker due to having much less, the data volumes wasn't that big, so we would gain any benefits of doing it multi-threaded, distribute out the workload. Right, cool. We can also do it in a programmatic way. I'm just jumping all over the place here. So we are basically getting exactly the same result in 3 different ways. One through the lifetime library, one through SQL, and the third time through PySpark. Anyway, we're not interested in that. We are now, when we are doing data science, and Sean can talk to this because he is an awesome at data science and AI. We are talking about holdout period, where we are kind of using a training set, and then we are having carving out a period which we will use as validation to test against that our model is what it is supposed to be, and we're calling that holdout. We are just saying that this should be for 90 days. And let's calculate this through the holdout values. Come on. Don't do this to me. There we go. But here we're now having we've seen the frequency, the recency, the age that we talked about before. We have a monetary value, and now we're seeing the values for the frequency during the holdout period, the monetary value for the holdout period, and the holdout period in itself. Do we need this? Do we need this? Yeah, let's just run that, which gives us the same thing, but in by using the PySpark API. Cool. There we go. We can compare the result. We're not interested in that. What we are doing here is that we are filtering out customers. So here we are filtering out customers that has more than one purchase, and we are doing that for the testing data, or for the training data, as well as for the validation data. Cool. And we are doing the same. So now we have filtered out customers that doesn't have any purchases whatsoever. Now we just want to make sure that we're having certain monetary values. I could actually just have done this command here if I wanted to, but anyway. We are doing some checks to see that what we have is correct. And now we can go on and train the spend model, where we are using a model called Gamma Gamma, which you can read about what it's doing. We are using things called the hyper optimization parameters in an L2 regularization parameter. Read about it. I cannot for the life of me explain it. I'm sorry. So we run that, and we are getting down to now creating these hyper optimized parameters. I have already done that, so I'm skipping that for now. I already have those values. Now what we are doing is we are training the model, and having trained the model, we can evaluate it, and we are using mean squared error for that, where we're looking at the actual value versus the predicted model, and we're looking at the mean square error based upon that. We're getting a value of 2787. The smaller this is, the better. We can argue that this is way too high, but we will see in a couple of, well, in a minute or two, that this is actually not that bad. So the mean square error gives you kind of it gives you how well your training data, your data based upon training, fits into the actual data. So we can plot this, and what we will see now is so the yellow thing here, I don't know if you can see it. The yellow thing here is the predicted value, and the blue is the actual value. So we can see that this kind of fits fairly well. The model we have here is not that bad. Yeah, if that makes sense. Don't forget, once again, I mean, you may, when I saw this first, I was saying, yeah, how hard can this be? But don't forget, I mean, this could now be huge volumes of data that we are working with. And we are doing this in a very, very performant way. Cool. Let's now train a model. We are doing that. And where we now have everything, we can now calculate the CLV. And we are saying that one thing that we need when we are calculating the CLV is we need the discount rate. And we are doing it on a monthly basis. And here we have set the discount rate to, well, kind of 1%, 12%, 12.7% annually, and someone needs to give that to you, needs to give that to whoever is doing these calculations. But apart from that, we have all the values already, right? And now we are seeing here, right? So here's now the output, right? That customer ID have a calculated CLV of 3,000 something, 900 something, 600 something, right? And you can now use this to see, should I spend money on retaining this customer? And we can merge this with the aliveness probability, right? So if we are seeing that, this 1, 2, 3, 4, 7, his CLV is fairly high. If we are seeing, which we don't have in here, but if we had it, if we saw that his aliveness probability was kind of lowish, then maybe we are deciding that spend money on this customer to retain him. So the aliveness percentage is, what is the chance that he will be with us in the future? If that is on the lower side, but the CLV is high, then sure, let's spend some money on this. Does that make sense? I hope so. Cool. Let's save this model. Let's wrap it into a, let's create a wrapper around this model so we can use it in an easy way. Once again, I'll share this code so you can look at it and for yourself see what it's doing. We have now created this. Let's save it off to MLflow. So MLflow is a machine learning library in Apache Spark in Databricks, and having it in MLflow, we now have the ability to create a function based upon this, which we are doing here. And we can then use this function. So now we have a function that doesn't really, me as a user, I don't need to know I don't need to know the inner workings of this function, right? I can just use it, and I can now have I can have some job that runs continuously and calculates future spend of a customer, that calculates the aliveness probability. And if I then see in this job, I'm now seeing that I have a low aliveness probability versus a high-ish future spend, I fire off an alert saying that, hey, this Sean customer here, we are running the risk of losing him, but he has a high potential future spend. Let's do something with him. Let's spend some money on him. Let's give him some extra discount, what have you. So having created this, we can then use it, as I said. And now we are using it against existing data, and we are now seeing the results. So customer ID 12347, a CLV of that, which we saw before. But now we are using the function where before we were using the model directly. And we can also do this in SQL, in Spark SQL. So once again, we have now potentially used, targeted lots and lots and lots of data in Databricks, Apache Spark. We have created a model, and we are now running just a function against some data, and we can see a potential future spend. Did I? And that's kind of where we're at, right? So to sum it up, that we can improve CLV, can help to improve revenue, because by using CLV, we can target our retention campaigns. We can target the way we are doing retention with the help of Databricks. We have the ability to calculate. We can go down on an individual level and calculate customer lifetime value, which was very, very hard to do before due to the volumes of data needed for this. Can we do this in real time? Even better, because then each interaction that a customer have with us, we have the ability to look at the CLV and make decisions. And what we are doing, so as I said, Derivco, we are doing online gambling, where we have models where we are looking at a person's interaction with us every time he spins on a slot machine or is doing something on a blackjack or whatever. We are kind of calculating to see what is his aliveness probability, what is his potential future spend, and then we have automated scenarios that if the aliveness probability is less than, pick a number, if the aliveness probability is less than 50%, but his future spend is higher, potential future spend is higher than Y, then do something, send him a message, give him some bonus money, what have you, just to prevent him from churning. So yeah, keeping valuable customers easier than getting new ones. Once again, do not keep non-valuable customers, right? Keep the valuable customers, and do all this in real time. That's that, boys and girls.